Okay, hi everybody. There were some, it looked like some people were confused today about how to propagate the uncertainty, how to calculate the uncertainty given your data in your lab today. So I wanted to explain it to you just very quickly. So I want to start with assuming that you have the time for 20 complete revolutions or oscillations. So let's say it's 15 seconds, so that's the number that I have right here. Now the period of oscillations is just going to be your time for 20 revolutions divided by the number 20. So the period of oscillation is just going to be 15 over 20, which is 0.75. I have no idea if these are the numbers you're going to get. I'm just making these up to show you how it works. The frequency of oscillations is going to be 1 over the period. So frequency is equal to 1 over the period. So frequency is the cycles per second. Period is the seconds per cycle, so that should make sense. And 1 over 0.75 is equal to 1.33. So your frequency of oscillation should be 1.33, and that's in hertz. And your frequency squared should be the square of that. So we're just going to take our 1.33, which is there, and we're going to square it. And we get 1.78. So that's 1.78. Keep your decimal points to something reasonable. So maybe 2 decimal points makes sense. So that part seems okay. Now the period down here, where we're propagating the uncertainty, the period is going to be the same as what you have up top, except there's going to be a plus or minus. So you're going to have 0.75 and then plus or minus something. The frequency is going to be 1.33 plus or minus something, and the frequency squared, this should be lowercase f, is 1.78, and then that's also plus or minus. Now this is the part that was causing people problems. So in order to calculate the uncertainty, we start with period. So what's a reasonable uncertainty in period? I don't know. When I've done this, I feel like if you have 20 oscillations, maybe it could be plus or minus 1 second. But you don't need to use that. You can use something that seems reasonable for you. But for me, that sounds reasonable. About a second in 20 oscillations, or 20 revolutions. So for 1 revolution, that's 1/20th of a second, so 0.05 seconds. So our uncertainty in our period is going to be plus or minus 0.05. And that can be anything, but it should be 1/20th of whatever your uncertainty is for 20 revolutions. Now to find the uncertainty in frequency, we're going to find the maximum possible value and the minimum possible value that we can have for the frequency. So the maximum possible value is going to correspond to the minimum period we can have, which is 0.75 minus 0.05, which is 0.70. That's the minimum period within the uncertainty. The maximum period is going to be 0.75 plus 0.05. And so that's going to be 0.80. And that's the minimum period. And so if we want to calculate the minimum and maximum frequency, we're going to take 1 over 0.7, which gives us 1.43, and 1 over 0.8, which is 1.25. 1.25, see? So 1 over 0.7 equals 1.43, that's hertz. And then 1 over 0.8 is 1.25. So that's the range of frequencies that you can have. Now the difference between those two, 1.43 minus 1.25, is equal to 0.18. And so half of the range, that gives you your uncertainty. So you take that and divide it by 2, it's 0.09. So our uncertainty in our frequency is 1.33 plus or minus 0.09. The point of you going through this is to see that the uncertainty gets bigger and bigger and bigger the more you do with the data. So now if we want to find the uncertainty in frequency squared, we're going to take our maximum and our minimum frequency and we're going to square it. So f squared, the maximum value is going to be 1.43 squared. And I'll make that big so you can see it. I hope you're enjoying this. I'm missing Terra Nova so I can make the screencast for you. I don't know if Terra Nova is really very good though. Do you guys like it? You can tell me tomorrow. 1.43 squared, that's 2.04. And then for the minimum value, we get 1.25 squared. So that's, hold on, not 2.04, because that's not 1.43, that's 1.25. So we can take 1.25 squared, and that's 1.5625. Round that to 1.56. So that's the minimum and maximum frequency squared, the difference between them. So 2.04 minus 1.56 is 0.48. Half of that is 0.24. So our uncertainty in f squared is 1.78 plus or minus 0.24. That should do it. Let me know if you have any other questions.